Hello students, today we are going to study the topic types of overlapping in covalent bond and hybridization, just an introduction. So here types of overlapping of the covalent bond, on the basis of the overlapping it is of two types, this covalent bond, sigma bond and pi bond. When we talk about sigma bond, they are end-to-end overlapping around the internuclear axis. So let's just see three types you can see in this sigma bond overlapping here: SS overlap, SP overlap and PP overlap. How it comes? See here, this is S orbital. SS spherical in shape. When overlapping takes place around the internuclear axis, it is known as what? SS overlap. When S is there and PP has got dumbbell shape, isn't it? So what happens here when there is overlapping around the internuclear axis, we are saying that what? SP overlap. And when we are talking about this, both are dumbbell shape, so P orbitals, isn't it? When they are just overlapping end to end, around the internuclear axis, it is called as PP overlap. So these three types of what? Sigma overlap, we can see that is SS overlap, SP overlap and PP overlap, and these are all what? Sigma bonds. Now coming to the pi bond. Pi bond is what? Perpendicular to the axis. Here it was internuclear, here it is perpendicular. So now you see, this is what? The P-shaped shell, it is what? Dumbbell in shape, isn't it? What happened? Overlapping takes place, above the plane and below the plane. And as the result, you can see when we represent it one above and one below. And you can see here this overlapping, it is what? It is parallel overlap, and here it is what? It is sidewise overlapping, I will say, not end to end, it is sidewise overlapping, above the plane and below the plane, and it is known as what? PP overlap here, because here which is present? P only, isn't it? No S we can see over here. So this is what? A pi bond. So now when we are talking about sigma bond and pi bond, there are a number of differences, but the main difference is what? Here this sigma bond is a strong bond, because this is end to end overlapping, isn't it? And if overlapping is more, as the result to break it, it becomes difficult. But when we are talking about the pi bond, it is above the plane and below the plane, isn't it? And so here the bond will be not so strong, The bond will be not so strong and it can break easily, So this is all about sigma bond and pi bond. So students, in the previous video we have studied what the overlapping in case of methane molecule, it should be how much? 90 degree, but it was not that, isn't it? It was coming some different value. So that I had said you that we will be understanding in the concept of what? Hybridization. So here we are going with that, which will tell about what? The shape and in the energy also. So here what is hybridization? Hybridization is the process of intermixing of the orbitals of slightly different energies so as to redistribute their energy, resulting in formation of new set of orbitals equal in shape and size. So what happens in this hybridization? There is intermixing of the orbitals, and those orbitals, its energy should be not having a vast difference. It should be only slightly different in values of the energy. So here what happens actually, here when the intermixing of the orbitals has taken place, what happens? This newly formed this orbitals, it will have what? The same shape as well as the energy. How it comes, let us understand. This methane molecule, it is having how much? 2s and 2p. And it is said to be hybridized, having what? 4 orbitals having the same energy, and that is known as what? Hybrid orbital of what? And it is known as what? 4sp3. How it is coming? Like carbon, it is having what? 6 atomic number. It becomes how much? 1s2, 2s2 and 2p2, isn't it? Taking the last one, this is in what? Ground state. When it is forming the hybrid orbital, see what happens in the ground state. okay, 2s2. P has got how many orbitals? 3, isn't it? So 1 and 2, okay, this is empty. But what happens in the excited state? This electrons moves, isn't it, over here? And now what happens? This is what the hybrid orbital. Now, in which one s is there and what? 3p is there, isn't it? And as the result it becomes what? sp3 having what? Same energy. Okay. So students, the overlapping concept of atomic orbital could not give the shape and geometry, isn't it? But yes, the hybrid orbital could give. Okay. So but when we are saying about this hybrid orbital, number of hybrid orbital is always equal to the number of what? Atomic orbitals. Okay. So hybrid orbital, when we are talking about that, they are always equivalent in energy and shape. Right now I have explained you. Okay. Hybrid orbital, they are stable than any pure atomic orbital. Okay. They are more stable. Okay. Now, hybrid orbital, when we are seeing, okay, when wherever there is minimum energy between the electron pairs, the direction of hybrid orbital is on that side only. Okay. So, the type of hybridization, okay, always says about the geometry of the molecule or the compound. So, what are the important conditions of hybridization? Okay, let us see that. Okay. So, the orbitals which are present in the valence shell, means the outermost shell, only gets what? Hybridized. Okay. They participate in hybridization, not the inner ones. Okay. Now, when the orbitals, okay, hybridization takes place, they have got what? Equal energy. Right now I explained to you in case of carbon, okay, when it was becoming sp3. So all the orbitals, whether it is s or p, were having same energy. Okay. Now next, promotion of electron is not essential condition prior to hybridization. What does this mean? This means that when, suppose if a methane molecule is being formed, okay, I showed you what that carbon was getting hybridized in this, like I showed you, it is having how many? 6 electrons. Okay, configuration done, 1s2, 2s2, 2p2, okay, made the orbitals, okay. I am making the last. I said to you what? The valence shell. Okay. So what happened? We are doing what? This carbon is getting excited. What? Nothing is to do with what? This hydrogen. Okay. First this excited state comes and then only the electrons participate. Okay. And in bonding. So here promotion of electrons prior to hybridization is not essential condition. Okay. Now, when we are talking about hybridization, it means something is like here I said that here it is free. Okay, so it is half filled. Okay, so it is not that if the orbitals are half filled only the hybridization can take place. Sometimes even in fully filled also orbital what hybridization can take place. Okay, so this is all about today, the hybridization and overlapping of the orbitals. Okay, you hope you might have understood it. In the next video we will be studying about the types of hybridization.